Well, hey guys, welcome to 6.3 Graphing Linear Equations. And this is the very last section in our unit talking about just putting tables together, being able to graph linear equations, and basically putting all of our skills together up to this point. So I just wanted to draw your attention to this and just make sure that you're watching exactly how to do this, because there'll be a whole bunch of little things that you'll need to know. So the question that we're answering right here is this graph a linear equation question. And it says, the world's largest cruise ship, Freedom of the Seas, uses fuel at a rate of 12,800 kilograms per hour. The fuel consumption is represented by F in kilograms, can be modeled by using the equation F equals 12,800 T, where T is the number of hours traveled. Create a graph to represent the linear relation for the first 7 hours. Now, you guys, this is actually, I just want to talk about this in relation to physics next year. You're going to see a lot of these types of formulas with letters that you may or may not be familiar with, but we need to know how to manipulate formulas and to not be fearful of the letters. So, so something that I wanted to just show you right now is the first step that you always do is write the formula. This will always be for marks when it comes to just my stuff, but the other part is in high school you'll need to always write the formula as well, because you'll be manipulating a lot. So that's a really important step in this particular chapter. So it gave you the formula in the question, you found it with the letters and the numbers right there, and that's what I just wrote right here. The other thing that I want to talk about is building a table. And so every time in this unit that you see a question, you need to make a table of values, which we're starting to make right here in this particular section. The things that I want you to take note of is that the first section of the table is always considered the x values, and the second section is always considered the y values. This never changes. It's always the same. It will be the same from now until forever. It's really important for you to understand that, because it helps us actually decode the rest of the questions. I'm going to write the formula again right here. F equals 12,800 T. And so what's important about that is that we need to make sure that we know which letter is the x and which letter is the y. And the only way that I do that is I actually rewrite the formula underneath it. Y equals 12,800 T. Or sorry, x, my bad. So this is the x value right here. So how do I know, you might say, dudes, how do you know that this is the x value and that's the y value? Well, guys, listen, every single time the y value is always in the front of the equation, and the x value is always sitting right beside the number in the multiplier section. So that's always going to be the same from now until forevermore. So what I'm actually going to do is I'm going to go ahead and I'm going to take my these values here, and I'm just going to write them right beside this. So the y value is also the f value, and the t value is also the x value. This is going to help me solve my equation, because we're going to take a look at how to write it. So if you remember, always this is the x and that's the y, you'll always be good to go. So the first thing that it asked us to do was to build a graph and to represent the linear equation for the first 7 hours. The only way to build a graph is to build a table first. So we take the formula and we write it out like I said, and we use something called substitution. Okay, and so what you're going to do is you're going to substitute these values in the x into the x value, or what we would call in this formula the t spot right here, and get the answers. So the first one I'm going to do is this one right here. So I'm going to substitute it into this formula. So F equals 12,800 times, and I'm using 1. So I substituted it and I multiplied it and I got 12,800, and that's what I wrote right here. Then the next one I'm going to do is substitute the 2. So I'm going to substitute the 2 value and I multiply it together and I get this. And then we go through and we multiply all of them. The f of this one here was the 3 value, and so we got 38,000. And we would just go through and consider finishing this. So because I never did it on my sheet for the notes, we would be doing it in class, I'll just do it here. The 4 value is 51200. So I'm going to put 51200. The fifth value would be this times 5, so 12,800 times 5 is 64,000. 60 4,000, and then I'm just going to do one more. F equals 12,800 times 6. 12,800 times 6 is 76800. 76800. Okay, cool. So we have figured out now how to build a table of values in order to graph our results. So these are the results. These are actually the coordinates that we're going to use on our graph. 1 and 12,800, 2 and 2,500, 25,600, 3 and 4. And we're just going to find these values up on this particular graph and be able to put them in. Now, a few important things about the graph itself. In order to do a correct graph to get full marks, you must always have a title on the top, you must always have a title on the side, and you must always have a title on the bottom. Something that I've forgotten that also is important in physics is you always need to have what things are measured in. So time was measured in T, and we used F for fuel consumption, so I'm just going to write the letter F above that for now. So we would graph this by using our coordinates 1, 12,800, 2, 25,600, so about here, 3, 38,400, and 4, 51,2, so about here, 5 is 6,004, so about here, and just so on. You'll notice that it's basically a linear graph. So that's how you graph, by using these coordinates right here, and we stick them onto our graph. So that's how you graph that linear equation. The next question says approximately how much fuel is used in 11 hours. Well, guys, here's the deal. There's a few ways that you can do this, but obviously from home, the easiest way is to use the formula. But I am going to tell you right now that we could 9, 10, 11. Use the graph, and we know that it's basically going up linearly, as you can kind of see. So we probably, if we had a nice sheet of graph paper, we actually probably could figure out how much 11 was by using the graph, but I'm just going to use the formula. So when coming back into this question, we're asking how much fuel is used for 11 hours. So what we do in physics is we write down what we actually have. So I'm going to write the formula first. F equals, and then it's 12,800 T. It asked how much fuel is present at 11 hours. So guys, in physics, we would actually write down this. We would write down our F, and we would write down our T, and we would write for time 11 hours, because that's what it's asking. The F we don't know. Then we fill in our blanks in our formula. F equals 12,800, and then we would substitute this 11 into the T spot. We would do the math, and we would be able to calculate that it will equal, F equals 140,800. And because fuel consumption, I believe that it was measured in, what was it measured in? We didn't say, probably liters. So I'm just going to put liters right here. And that would be like if you were in high school, that'd be how you get all your marks. How long can the ship travel if it has approximately 122,000 kilograms of fuel? This is in kilograms. All right, cool beans. Verify your answer. So I'm just going to write down what I know. So we are given this value, 122,000 kilograms, and that's in the fuel. 122,000 kilograms, and we want to know how much time. The first thing that we always do is we write the formula that we were given. So there we have it, and then we fill in and substitute. So I'm going to be using this underneath the F. 122,000 equals 128,000 times T. All right, how do I solve this? Well, I'm solving for my variable, which is T, so I need to do my dividing. So I would divide by 128, and bam, that, divide by 128, and bam, that, 122,000 divided by 12800, and that gives me 9.5. So the time here would be 9.5 hours. And so that's how you solve for variables when you don't know what they are. Keeping in mind that we always write the formula that we know. We write the variables that we understand from the question. We look at the one that we're looking for and solve for that value. And so that's how we solve for that particular problem. This particular section right here is extremely important, and we haven't done a ton of work on it yet, and I don't want to spend too much time yet pushing into this, but guys, from now until eternity when it comes to math, we've just been practicing this a bit. We need to know this lingo. Decrease by is always subtract. Increase by means addition. Times means multiply. Halved means divide by 2. A number is always the thing you're looking for, so it's always like x. So here's the next type of question that you're going to get in your textbook, and it's going to say graph the linear relation y equals 2x minus 5. Now, hey, remember back in the day, 2 minutes ago, when I told you that equations in high school, linear relations and equations in high school are always written y equals something x minus 5. I'm going to get into this in a second, but I'm telling you, you will always see the y in the front and the x always hooked up beside the number. In order to graph this, we have to make a table. There's really no other way. So this is important for you in this particular unit, is that we have to make a table. Well, how do we make a table? We do this thing called substitution. Right? And we write the formula, which is y equals, I'm just actually going to write this. Oh, sorry, guys. I'm just going to write this right here. Y equals 2x minus 5. And I'm going to substitute these values. Now, you always want to use values about 1 to 4. You can also use 0 in it, but I want you to use minimally 4 values when you're solving. This is because it's important when it comes to linear relations to have more than 2 values so that you can see that it's a straight line, and just to verify. So you're always going to choose 4 values. I suggest using 0 to 4 or 0 to 3 or 1 to 4. All the time when you're making a chart. So your chart, your x values should always be 1, 2, 3, and 4. All right, so substitution, you can see that I've already sort of showed you this blank canvas of how to do it, but we're going to start with 1, and so you get the idea. Y equals 2 times 1 minus 5, and so we would have y equals 2 minus 5, and so 2 minus 5 is negative 3, and that would go right here. In this part, we would go y equals, we're going to do the second one now, y equals 2 times 2, so I'm using this value now, plugging it into the x value. So 4 minus 5 is negative 1. So this value up here becomes negative 1. And when we go here, we'll just complete the table. 2 times 3 minus 5. So that's 6 minus 5, which is 1. So that will just be a 1. And the last one is y equals 2 times 4 minus 5. So that will equal 3. And so now you can see, guys, that we've actually been able to create a table of values with the x first and the y second. Now it's given us these coordinates that we can work with on the graph. The next thing you're going to do is graph them. 1 and negative 3, so starting at the x, going down to negative 3, 2 and negative 1. We've got 3 and positive 1, and we've got 4 and positive 3. And there you have it. So this is your linear equation. This graph, y equals 2x minus 5, equals the graph below. So great job. We made a table, we substituted, we graphed. The next question here says, what would the y value be if x equals 8? Again, the first step is always to write the formula. This will get you marks. Y equals 2x minus 5. It's giving me the x value, which is this value right here, so easily substitute that in. Y equals 2 times 8 minus 5. So that would be 16 minus 5. 16 minus 5 is 11, so y equals 11, and that would be the answer for this particular question. All right, so the next type of question, and basically we're just continually building, is actually being able to find an equation of a line. So we have to go one step further, take it from the graph and bring it to an equation. So step one, always, what is it? Make a table. So it gets a little bit monotonous, but guys, we always need to make a table. On your table, you're always going to have X in the first spot, Y in the second spot. We're going to use, actually, we need to use our particular spots here. So we're just going to use these dots. And so I'm going to go from the very first one and use 4 of them. -2 and -2. This one looks like -1 and -1.5. Okay, this one is 0 and -1. And this one is 1. Just extend this a little bit more. 1 and -0.5. And then this one is 2 and 0. I think I'm going to stop there. That looks like enough for me to be able to derive my formula. All right, guys, so the next part after you make a table is to find the pattern, and we need to basically make our chart. So I'm going to extend my line here just to do my little chart that we were doing. So we said multiply by, and we said add or subtract, okay? So I'm just making my little table here. First thing we need to do is find the pattern. And we need to remember here that even though we're starting in negative numbers, we need to make sure that we understand, are we going up or are we going down? And it looks like we're going from -2 to 0. Whenever the graph goes into the coordinate of the right-hand side, so this coordinate right here, it means that the graph is going to be positive. So what we're going to do is, I notice that it's going up by 0.5 every time. 0.5 plus 0.5. So that is my multiplier. So I'm able to just go multiply by 0.5. So I'm just going to make my little table here. Remembering back to last chapter, we need to multiply this 0.5 to here. So if we go -2 times 0.5, we get -1 in this spot. If we go 0.5 times -1, we should get -0.5, and this one should be 0. Is that right? Yeah, and this one should be 0.5, and this one should be 1. Okay, so this is how we get our next section, and then we got to get our add or subtract part. So we already know that it's y equals, and we have our multiplier 0.5x, because that's what this number is. It always goes beside the x. All right, cool. So let's see, how did we get back to these numbers? So it looks like we had to add, we had to subtract 1. So -1 minus 1 is -2. Look at this one. 0 minus 1 is -1. So mine is -1 here. And so then we'll get the same as this table right here. 1, 0.5, and 0. Cool. And so we're always just minusing 1. So that's our deal. And so that is our formula right there. Awesome. So we got our formula and we got our equation. So again, we made a table. We were able to find our multiplier, put it here, and go from there. So that's basically this particular unit. Now, I wanted to talk a little bit about high school because, you guys, this, like I told you before, this particular unit takes up 40% about of your grade 10 year. I want to show you what you're going to see next year, and it's going to come up quite soon because next year's coming up soon. But this is the formula for an equation for a line. Y equals mx plus b. The letter m represents the slope of the line. So the slope of the line is basically how, what the grade of the line is. So if you were riding a bike on this line, I'll just, you're riding a bike. Oh boy. Yeah, awesome. Okay, so you're riding a bike on this line. It's just basically saying, how high are you going up or how high are you going down? Slopes of the line is represented by the letter m. And there's a formula here, and it is determined by the rise divided by the run. If you guys take a look over at this particular graph right here, I'll show you how to calculate the slope of a line. So right now what we're doing is we're figuring out the pattern in a graph, and we're figuring out the formula from here. However, in grade 10, you actually are going to have to figure out this letter right here, which is called the slope, by using this formula, rise divided by run. So what rise means is it goes up, and so we would count 1, 2, 3 so we're just going to take 2 points, on the line. I'll draw them right here. We're going to take the intersects of the line. So you notice how the line goes through the intersects. And then we're just going to go rise. So we're going to basically see from how many jumps did it go to get up. So from here, it's 1, 2, 3 boxes. That's why I put the rise as 3. And the run is, so from here to here, you kind of make this triangle, is 1. So 3 divided by 1 is 3. And so this particular formula is y equals 3x minus 1. Now, I want to tell you guys something super, super cheap, okay? And this is something that not everybody explains in grade 9. This number right here, the plus or minus number, is called the b, which is actually the y-intercept. That means where the line goes through on the graph on the y part right here. So if this was 1, the y-intercept would be positive 1. So guys, check this out. I can actually build this formula by actually looking at this graph and not doing this crazy table every single time. So we need to understand down here, this is negative 1 right here. So where the graph crosses the y-axis is this particular number right here. It's actually super cool that it is that way, and that's how we can solve the answer. If you notice here, it says that the b on this line is a 1. So if we were to write out our formula, y equals, and I don't know what the slope is right now, I'm going to say it's 2x, we would say plus 1 because the graph goes through plus 1 right there. It's super important to take a look at this and to see this for grade 10 because this is high school and this is how graphs are written. So when you're writing something like y equals 2x plus 1, you're making a linear equation. You're basically figuring out what the slope of the line is, and you're figuring out the y-intercept, where it goes through the line. That's crazy important because that is a huge part of your grade 10 year. Moving on to graphing horizontal and vertical lines, you've got to know what the table looks like. So guys, this is actually pretty simple, but when you graph a horizontal line, remember that the horizon is like where the sun rises on, and so it's that straight line across. Again, this person has chosen 1, 2, 3, and 4. So they've chosen these right here to graph. And a horizontal line has the same number in the y spot every time. 3, 3, 3, and 3. Why? It's a horizontal line. So you need to know that the y is always the same when it's a horizontal line, okay? Anywhere like that. So the y value is the same. The equation here doesn't have an x. It's literally y equals 3. Why is it y equals 3? That's so weird. We've been writing like y equals 2x minus 4, and this equation, or horizontal line, is y equals 3. Well, guys, that's just because every single value is always going to be 3 for this particular line. So that's just why we say y equals 3. There's no real equation that we can write for it. When it comes to a vertical line, which is the up and down line, we need to look at it a different way. Look at the x value is always 1, right? The dot's always in the 1 spot. The y value starts to change, and you'll notice here that it's like 1, 2, 3, 4, because this is what we're doing here. But the x value is always staying the same. So we need to understand in a vertical line, the x value is always the same. The equation of this line is just literally x equals 1. Why? Because every single time we want to extend this line, x is going to be 1. If we want to be x equals 3, it would just look like this, because we would just go on top of the 3. I want to talk a little bit about positive slope and negative slopes of lines. I just want you to know that whenever the graph goes up into this quadrant right here on the right-hand side, we have a positive slope. That means that the equation will always have so y equals 3x plus 1, 2x plus 4, y equals 10x plus 6. See this number right here, guys? The front number in front of the x is always going to be positive. A negative slope always actually, it's kind of weird because we think it would go down here, but it doesn't. A negative slope goes down into the bottom right-hand coordinate. Negative slopes look like this. Y equals negative 3x plus 2. Y equals negative 2x minus 4. Y equals negative 4x plus 6. Notice how in this particular deal that all of the x values are negative, and so we know that the line is negative. A horizontal slope, dude's driving along that straight line, and a vertical undefined slope is when it's going straight down. Again, just something that we need to look at for graphing and understanding for grade 10 and for this particular chapter as well. There is one more thing I do need to show you before we actually can finish this, and this will trip a ton of people up. You guys, sometimes there are questions where your graph does not go up by 1. So I just want to kind of show you an example of that before you kind of leave today. It's probably the most important thing, and it's the one thing that kind of throws everybody off. Sorry, I just need to find my little example here. If I had an x and a y value of 0, 5, 10, 15, and 20, and then my y values were 0, 20, 40, 60, and 80. I want to show you something, okay? Look at this right here. These guys, they are not going up by 1. They're going up by 5. So the pattern on this side is plus 5. Plus 5, plus 5, plus 5. The pattern on this side is not plus 5. It's plus 20. Okay, I know that you can see that. I know you're good at that. But guys, we can't write y equals and have a formula here when this side is going up by 5s. We want to bring this side down to being going up by 1s. So what do? We have to actually divide this whole side by 5 so that it goes 0, 1, 2, 3, 4. All right, so let's check this out. 0 divided by 5 is 0. 5 divided by 5 is 1. 10 divided by 5 is 2. 15 divided by 5 is 3. 20 divided by 5 is 4. Do you notice now that the graph is now in a position that I can work with it? I could not work with it before when it was going up by 5s. Now I can. But the same thing happens when we're talking about rules. Whatever I do to one side, I have to do to the other side. So guys, I'm going to change the y-axis here. 0 divided by 5 is 0. 20 divided by 5 is 4. 40 divided by 5 is 8. 60 divided by 5 is 12. And 80 divided by 5 is 16. Now I can write my formula. Y equals, what's the pattern here, guys? So this is actually an easy one. It's plus 4, plus 4, plus 4, plus 4. Y equals 4x. And guys, if we did the whole chart, you would find that we're good to go, that this is actually the answer, because if I substituted in, like, say the 1, y equals 4 times 1, it would equal 4, and that means that we are in the same place. So I just wanted to show you guys that you have to, on a graph that doesn't go up by 1, you're going to have to be able to make sure that you adjust it and make sure that you're able to do that, okay? So that's super important, and I just want to make sure that you understand that on your pages so that doesn't throw you off on your formulas. That is all for this unit. Make sure that you understand it really well. Ask any questions that you have. You might need some graph paper at home. If you don't have any, there's some in the question that I've provided for you, if you can print it. I will provide an online graphing thing that you can use in your stuff, or you can just use your line paper and just make it as good as you can. So peace out. Have a great day.